Good evening to my favorite people. Glad to have you back. Today I want to teach you how to use the same substitution strategy as yesterday, but when only one equation is in slope-intercept form rather than both. So if you would, make this your next title and close that up and concentrate, clear out those distractions, and unpause when you're ready to go. Yesterday I taught you the substitution strategy. Substitution strategy worked like this. We took, in this case, both equations were in slope-intercept form. And that was handy because we could say, okay, well, if y equals this and y equals this, I can take one of my equations and I can replace y or substitute for y something that's equal to it, like that. Literally replace it or substitute 7x minus 6 in its place. And then now I have an equation with only one variable, and when there's an equation with only one variable, I can figure it out. To find x here, I would take 3x off both sides first. It's going to leave me 4x minus 6 or plus negative 6 equals 2. Next thing I would do is I don't want that there, so to cancel out the negative 6, I would add a positive 6 to both sides. That's going to leave me with 4x equals 8, which means x equals 2. And once I know x, I can go back to my original equations to find y and say, okay, I know x, so I'll plop x in there. X is 2. 3 times 2 is 6, plus 2 is 8. So that's what we did yesterday. Both equations were in slope-intercept form. Super nice, super easy. Sometimes you run into situations like this, where one equation's in slope-intercept form and the other is not. And believe it or not, it doesn't look like a great situation for the substitution method, but it actually turns out to be a pretty good one. In this case, we're going to use this same idea as yesterday, where we say, okay, check this out. In this equation, I know that y and all this are the same thing. They're equal to each other. So this and this are of equal value. They're the same thing. They're equal. I don't really have such a thing in this bottom equation. It's in standard form. It's not in slope-intercept form, so I can't just do what I did yesterday because I don't have a y equals to replace that with. But I still do have a y in the other equation right there. So what we're going to do here, if one equation's in slope-intercept form and one's in standard form, I still would like to have an equation with only y or only x so that I could solve for it. And I can do that if I say, okay, well, y is equal to this, so I'm going to substitute this stuff that has an x in for the y here, because y is equal to it. This stuff is equivalent to y, so I can replace this y with that, or substitute this y with that. So when I do, nothing happens here, 4x plus. Now I have 3 times all of this instead of y. Instead of y, I'm going to write something equal to y. I'm going to substitute 5 minus 2x in for y. Notice I put parentheses around it, because now when I solve this, well, let me finish, equals 13. I'm going to have to multiply 3 by this and 3 by this. If I didn't put parentheses, and I just substituted this like this, it makes it look like 3 gets multiplied by that, but not by that. 3 needs to get multiplied by everything y is equal to, the whole deal. So let me show you how to set that up one more time, because I know that's a big step. So I'm going to rewrite my standard form equation here in the bottom, 4x plus 3, except now I'm going to replace y with this expression here that y is equal to. Equals 13. I can do that because this and y are literally the same. They're equal to each other. So I'm just replacing it with something equal to it. Now, look what's happened. It's not easy to do, but I have made an equation with only one variable. There's only x's. And when I only have one variable, I can figure it out. It takes some work, but I can figure it out. So let me now add the opposite. Let me get rid of the subtraction. So first step in solving this is to get rid of these parentheses. I'm going to use the distributive property here. So I'm going to have 4x plus 3 times 5 is 15. 3 times negative 2x is negative 6x equals 13. Let's see, on this side of my equation, on the left, I can combine like terms. Those will make negative 2x plus 15 equals 13. My next step would be this, to add negative 15 to both sides. If I do that, 15 and negative 15 make 0, 13 and negative 15 make 2, and x equals 1. Most of the way there. Notice what I'm doing now, very similar to yesterday. Once you know how to do this substitution, similar to yesterday. So now that I know x, I'll probably go back. The top equation looks like the easier one to use to find y, by far. So I'll go back up to my first equation. Now I know x, and I can use x to find y. X is 1. So y is equal to 5 minus 2 times 1. That's 5 minus 2, so y is equal to 3. And my ordered pair is 1 to 3. So, pretty cool little method. I know y is equal to this, so I'm going to replace y or substitute for y. And then I only have x's. Pretty clever tactic. Let's do one together. Open your notebook up and write this system of equations down. And we're going to solve this one with the substitution method. So first things to note is this one's in standard form. This one's in slope-intercept form. And I can't use the substitution method the same as yesterday, but here's what I can substitute. So I know y and all of this are equal to each other. They're the same, correct? So what I'm going to do is, since this is equal to y, this is literally the same as y mathematically, I'm going to put all of that in for the y right there. I'm going to substitute that way. So I'm going to replace y with something y is equal to, which is all that. When I do, here's what I get. I'm going to get 2x plus 5 times all of this new y stuff, 3x minus 3, equals 19. So now I have the exact same standard form equation I had here, except instead of y, which was there, I replaced y, substituted for y, all that new stuff. Okay. From there, I solve this just like normal. It's work, there's parentheses, there's a lot going on, it's some work to do, but I can do it. I'm going to start with the distributive property here, plus opposite. So I'm going to have 2x plus 15x plus negative 15 equals 19. First step, distributive property here, if you want to write that, dist prop. I'm going to combine like terms next. This is my next issue, so I'm going to add 15 to make that go away. And I'm left with 17x equals 34. So x equals 2. Almost there, halfway home. So now I've got x. I'm going to use x to find y. This one's going to be the much easier place to do that. So now that I know x, I loop back to my original problem. In goes x here. I get y equals 3 times 2 minus 3. That's 6 minus 3. Y equals the 3. So my solution is 2, 3. Got it. So y'all, that is the substitution method with one standard form equation, one slope-intercept form equation. Boy, I know that's a lot. I don't know that I could possibly feel great about that with only 2 examples. So if you need to go watch this back through one more time to feel like class is going to go great for you tomorrow, I invite you to do so. We'll see you then.